that came from your Canvas lesson that you should have done at this point. If you haven't, you need to pause the video and do them by yourself first. But let's just go ahead and solve these. So these are both simple. There's no solving steps to take. We just apply the absolute value. The absolute value of x equals 3 is saying what values have a distance away from 0 of 3. So we split that up. That's x equals 3 and x equals negative 3. So our solution is 3 and negative 3. And this one's basically the same thing. It's saying what number or numbers have a distance away from 0 equal to 15. Again, we split that up because it could be 15 or negative 15, and that's my solution because I have no more solving to do. It's 15 or it's negative 15. If you've got questions on those, make sure you can leave them in the comments or contact me in some way. But otherwise, let's move to our next examples, where we're making a little bit more complicated now. We're adding a step here. So I want you to notice that what this equation says is if we take a number and subtract 3, it will be a distance away from 0 of 8. So what numbers, when I take a number and subtract 3, will have a distance of 0 away from 8? Well, there's an obvious one, which we can see is 11. However, it's not negative 11, right? Negative 11 doesn't work. If I have negative 11, this is negative 11 minus 3, which is negative 14. That is not a distance away from 0 of 8. So what do we do? And so for all of these absolute value equations, we're going to split the equation to find that other answer, the one that comes from the negative side, the left-hand side of it. We're going to split it up. So we're going to create two equations out of this. I'm going to make one equation that's x minus 3 equals 8. Notice that this equation over here is the exact same as what we see up here. Okay? We're going to create another equation, and this is going to represent the one that goes from the other side, the negative side. So it's x minus 3, but instead of equaling positive 8, I know that things that are negative 8 also have that same distance. So we're going to solve that. And notice that from this equation to this equation, that all we've done here is change the sign. Change the sign of the right-hand side. Notice that this on the left is still the same. That's one of the big common mistakes that I see as people are solving these. We see the x minus 3 and we want to take the absolute value and make that x plus 3. But that's not what happened. That's not what's happening. We're not taking the absolute value here. We are splitting it into 2 so that we can find both the positive and the negative solution. So now we need to solve both of these equations. So I'm going to add 3 over here, and I'm going to get x equals 11. And I'm going to add 3 over here, and I'm going to get x equals negative 5. So those are my two solutions, 11 and negative 5. And notice that if you take negative 5 and subtract 3, you get negative 8. But then you take the absolute value, which makes it positive 8, because it's a negative 8 is a distance away from 0. It's positive 8. So they both work, right? 11 minus 3 makes positive 8. Negative 5 minus 3 makes negative 8, which is a distance away from 0 of 8. So we had to split it up. Okay, that's that whole 2 equations, 2 solutions thing that we were talking about. Do a couple more examples. This one, more complex. Look, we have operations happening outside of the absolute value, right? This is 3 times the absolute value of 2x minus 7 minus 5 equals 4. We have to do some things before we split it up, okay? So before we split it up, we need to solve for the absolute value. Absolute, how to spell. absolute value. We have some steps that need to be taken before we do that whole split thing. Because remember, this says, let's take a number, multiply it by 2, and subtract 7. And the distance away from 0, when we multiply it by 3 and subtract 5, is going to be 4. That's a really complicated thing to say. And that's a really complicated thing to look at. So let's get rid of the two terms that are outside the absolute value first. Let's take care of that, and let's take care of that. Because once we do those two things, we can split it up in a much less complicated way. So I'm going to take care of this thing over here first. Opposite operations, we're going to get it by itself. We're going to add 5 to both sides. That's 3 times the absolute value, 2x minus 7. Now recognize that this is multiplying the absolute value. We don't distribute that because absolute value is not a set of parentheses. You can't just distribute. It doesn't work. However, since this is multiplying, we can divide. So we end up with the absolute value of 2x minus 7 equals 3. And notice that after doing those two steps, we have a problem that looks exactly like the one that we just did. And now we can split it up, right? At this point, since the absolute value is solved for, right? When I say solved for, I mean it's by itself. We can split it up. So let's now do what we did in the previous problem, because this says when we take a number and multiply it by 2 and subtract 7, it will be a distance away from 0 of 3. So what numbers, when I multiply by 2 and subtract 7, are a distance away from 0 of 3? Well, this either has to equal 3 or it has to equal negative 3. Notice that we're having to do quite a lot of work here, because now we have to solve both of these. So I'm going to add 7. I'm going to get 2x equals 10. I'm going to divide by 2, and I'm going to get x equals 5. There's one solution. I'm going to add 7. I'm going to get 2x equals 4. I'm going to divide by 2, and I'm going to get x equals 2. So those are my two solutions, x equals 2 and 5. Now I want to just point your attention to the fact that these are both positive numbers. That doesn't matter, right? We can still do this. Let's just check this out real quick. So let's plug in 2. 2 times 2 is 4. 4 minus 7 is negative 3. Negative 3 absolute value is positive 3. That 2 is representing the negative solution, right? Because when I plug in 2, I get negative 3. That's where I'm going to the left-hand side on that number line. When I plug in 5, I get 2 times 5, which is 10, minus 7, positive 3. Notice that I've still gotten the negative 3 and the positive 3, even though both of our actual solutions here are technically both positive. When I plug in 2, though, I get that negative 3. I'm going to do one more example like this, because I know these ones are a little bit complicated. So let's do one more example before I have you do it on your own. Okay? I'm going to solve for this particular absolute value right here. Right? I'm going to get rid of the minus 5 and the times 4 first. So I'm going to add 5, and that gives me 4 times the absolute value of 24. Then I'm dividing by 4, and I'm getting the absolute value of t plus 9 equals 6. Now that the absolute value is solved for, I'm going to split it into two equations. One of these equations is exactly the same as what we have over here. The other one, I'm going to change the sign. I'm going to make that negative 6 instead of positive 6. So we're going to subtract 9 from both sides to get this one. There's negative 3 is one solution. And then I'm going to subtract 9 from both of these ones to get negative 15. And so there's my solution. Negative 3 and negative 15 are the two numbers that when I add 9, take the absolute value, multiply it by 4, subtract 5, I get 19. Okay, back in your Canvas lesson, I have some extra problems for you to do. Their solutions are going to be in the next video, so go ahead and go back to your Canvas lesson. Give this problem a try, okay? And we'll check it out in the next video.